the untold story of Earth, from cosmic chaos to living planet. What if everything you've ever heard about the birth of our planet is only half the story? Imagine, for a moment, the world beneath your feet, solid, familiar, teeming with life. Now, picture that same ground as a swirling, chaotic sea of molten rock, drifting through the darkness of space, with not a single drop of water or a hint of life anywhere. It's almost impossible to believe, but the Earth we know today was once nothing more than a hostile, boiling sphere, surrounded by cosmic violence and uncertainty. The story of how this lifeless ball transformed into the only known oasis in the universe is far stranger and more dramatic than most people realize. For billions of years, the universe was a silent stage, waiting for something extraordinary to happen. Our solar system didn't just appear out of nowhere. It was forged in the aftermath of unimaginable destruction, shaped by forces so powerful they could tear entire stars apart. The ground you walk on, the air you breathe, even the water you drink, all of it is the result of a cosmic chain reaction that began long before the Earth had a name. But how did it all begin? What hidden events set our planet on a path toward life, while countless other worlds remained barren and cold? Scientists have spent decades piecing together this puzzle, uncovering clues from ancient rocks, distant stars, and even the surface of the moon. Yet, for every answer they find, new mysteries emerge. Was it pure chance that Earth ended up in the perfect spot, with just the right ingredients for life? Or was there something more, a series of rare, almost impossible events that set our world apart from all the rest? As we dive into the untold story of Earth's origins, get ready to question everything you thought you knew about our place in the universe, because the truth is, the real story is far more astonishing than any science fiction. But before we unravel the secrets of our planet's birth, let's journey back to a time before the sun even existed, a time when darkness ruled, and the stage was set for the most explosive beginning imaginable. Long before the Earth had oceans or mountains, before the sun ever blazed in our sky, there was only darkness, a vast, silent emptiness, stretching farther than the mind can imagine. In this endless void, a cold, drifting cloud of gas and dust wandered aimlessly for millions of years. This was the solar nebula, a ghostly remnant of ancient stars, filled with hydrogen, helium, and traces of heavier elements. It was a place of stillness, but hidden within it was the potential for unimaginable change. Then, in a single, cataclysmic moment, everything shifted. Somewhere nearby, a massive star reached the end of its life and exploded in a supernova, unleashing a shockwave that tore through the nebula. This wasn't just any explosion, it was the kind of event that can outshine entire galaxies, scattering the building blocks of planets and life across the cosmos. The force of the supernova sent ripples through the cloud, compressing pockets of gas and dust, and setting off a chain reaction that would change the fate of our corner of the universe forever. As the shockwave passed, gravity began to take over. The once peaceful nebula started to collapse in on itself, spinning faster and flattening into a giant, rotating disk. This was the protoplanetary disk, the birthplace of everything we know. At its center, matter piled up, growing hotter and denser with every passing moment. The rest of the disk, meanwhile, was a swirling chaos of particles, each one destined to play a role in the creation of worlds. But this process wasn't gentle. The early solar system was a place of violence and unpredictability, where collisions and chaos ruled. The same forces that would one day give rise to planets also threatened to tear them apart before they could even form. It's a story of destruction and creation, of cosmic dust being forged into something entirely new. What's truly astonishing is that this wasn't a unique event. Across the universe, similar clouds have been observed, caught in the act of collapsing and spinning, hinting at the birth of other solar systems. Yet, for reasons we're only beginning to understand, the conditions in our own nebula were just right, setting the stage for a star, a family of planets, and eventually, the emergence of life itself. But the story doesn't end with the birth of the sun. In fact, that's only the beginning. As the center of the disk ignited into a blazing star, the leftover dust and gas began a new, even more chaotic dance, one that would lead to the creation of planets, moons, and the very ground beneath our feet. And as we'll see, the path from dust to planet was anything but straightforward. At the heart of the swirling protoplanetary disk, something extraordinary was happening. As gravity pulled more and more gas and dust toward the center, the pressure and temperature began to climb to unimaginable levels. For millions of years, this process continued, the material growing denser and hotter, until finally, the conditions reached a tipping point. Deep within this cosmic furnace, hydrogen atoms began to fuse together, releasing a burst of energy that would change everything. In that instant, our sun was born, a newborn star, blazing to life in the darkness, its light cutting through the void for the very first time. The birth of the sun was not a quiet affair. It was a violent, energetic event, unleashing powerful solar winds that swept through the disk, blowing away much of the lighter gas and shaping the future of the solar system. The sun's gravity became the dominant force, pulling the remaining material into orbit and setting the stage for the formation of planets, moons, and countless smaller bodies. Even now, the sun holds more than 99% of all the mass in the solar system, a staggering amount of power concentrated in a single, fiery sphere. But the sun is more than just a source of light and heat. At its core, a nuclear fusion reaction rages, turning hydrogen into helium and releasing an immense amount of energy in the process. This reaction is the engine that powers our entire solar system, providing the warmth that makes life on Earth possible. Without it, our planet would be nothing more than a frozen rock, drifting through the endless night. What's even more fascinating is that the sun's birth was both a beginning and an end. The hydrogen and helium that make up most of the sun's mass were forged in the hearts of ancient stars, long since destroyed in supernova explosions. In a sense, our sun is a second-generation star, built from the ashes of those that came before. Every atom of carbon, oxygen, and iron in your body was once part of a star that lived and died billions of years ago. The story of the sun is, quite literally, the story of our own origins. Yet, as powerful as the sun is, it didn't form in isolation. The leftover material in the disk, just a tiny fraction compared to the sun's mass, was about to embark on its own journey. This 0.2% of the solar system's mass would become the building blocks of everything else: the planets, the moons, the asteroids, and the comets. It's almost unbelievable to think that all the diversity and complexity of our solar system came from such a small portion of the original nebula. But the process of turning dust and gas into worlds was anything but simple. The early solar system was a place of constant change, where chaos reigned and nothing was guaranteed. As the sun settled into its new role, the remaining material began to collide, stick together, and grow, setting off a chain of events that would eventually lead to the formation of Earth itself. And as we'll see, the journey from dust to planet was filled with danger, drama, and more than a few cosmic surprises. With the sun blazing at the center, the rest of the protoplanetary disk was anything but peaceful. Imagine a swirling, turbulent arena where dust grains, no bigger than specks, were constantly colliding, sticking, and sometimes shattering apart. This was the true beginning of the planet's, a process that, at first glance, seems almost impossible. How could something as massive and complex as Earth start from particles so tiny they were nearly invisible? Yet, in this cosmic chaos, the seeds of worlds were being sown. The process began with the simplest of interactions. Static electricity and chemical bonds caused dust grains to cling together, forming clusters that slowly grew larger. Over thousands, then millions of years, these clusters became pebbles, then rocks, and eventually boulders. But the real drama started when gravity entered the scene. As these clumps grew, their gravitational pull increased, drawing in more and more material. The disk became a battleground, with countless bodies racing to grow bigger, each collision a gamble between creation and destruction. Some of these growing bodies reached sizes of a kilometer or more. These were the planetesimals, the first true building blocks of planets. Their collisions were no longer gentle. They were violent, energetic impacts that could shatter or fuse entire worlds. And the process, known as accretion, was first proposed by Soviet astronomer Viktor Sakharov, whose ideas were initially dismissed as too radical. But as telescopes improved and scientists began to observe young star systems across the galaxy, the evidence became undeniable. Accretion wasn't just a theory, it was happening everywhere. Meteorites that crash to Earth today are like time capsules from this ancient era. When scientists crack them open, they find chondrostini, round grains that formed before the planets themselves. These relics contain radioactive elements, allowing researchers to date their origins and reconstruct the timeline of our solar system's birth. Some of the uranium found in these meteorites is even older than the sun, forged in supernova that exploded long before our solar nebula ever formed. It's a humbling reminder that the story of our planet is woven from the remnants of countless cosmic events, but the path from dust to planet was far from smooth. The early solar system was a place of relentless collisions, where planetesimals smashed together, sometimes merging, sometimes obliterating each other in flashes of heat and light. Computer simulations suggest that it took tens of millions of years for these bodies to grow large enough to be called protoplanets, some as big as our moon. Each impact released enormous energy, melting rock and creating seas of lava. The competition was fierce, and only the largest, most resilient bodies survived. It's easy to forget just how unlikely this process was. For every planet that formed, countless others were destroyed or ejected from the solar system entirely. The survivors, those that managed to grow large enough, would go on to shape the future of our cosmic neighborhood. And among them, one would eventually become the Earth, a world forged in fire and chaos, destined to become the cradle of life. But the story of Earth's formation was about to take an even more dramatic turn. As these protoplanets continued to collide and merge, the young Earth faced a series of cataclysmic impacts, events so intense they would reshape the planet's surface, its atmosphere, and even its destiny. The next chapter in our story is one of fire, fury, and the birth of a world unlike any other. The early Earth was nothing like the blue and green planet we know today. Instead, it was a world defined by chaos, violence, and relentless transformation. Imagine a landscape where the ground itself was a churning sea of molten rock, where the sky glowed red from the heat, and where the very air shimmered with the energy of constant collisions. This was the Hadean Ion, a time so extreme that its name comes from Hades, the ancient Greek god of the underworld. For hundreds of millions of years, Earth was a true hellscape, battered by impacts that would make even the most dramatic Hollywood disaster scenes look tame. During this period, the young planet was under constant assault. Protoplanets and planetesimals, some as large as mountains, others the size of small cities, smashed into Earth at unimaginable speeds. Each collision unleashed energy powerful enough to melt rock, vaporize water, and send shockwaves rippling through the planet's interior. The surface was a patchwork of lava seas, constantly reshaped by new impacts. Gravity slowly pulled the growing mass into a more spherical shape. But stability was still a distant dream. Yet, out of this destruction, something remarkable began to happen. With every impact, new materials were delivered to Earth's surface. Some of the objects that crashed into our planet carried a precious cargo: water. Scientists believe that many of the asteroids and comets that bombarded the early Earth were rich in ice, formed in the cold outer reaches of the solar system. When these icy bodies collided with the molten planet, the heat instantly turned their water into steam, which rose into the atmosphere. Over time, as the planet cooled, this steam condensed and fell back as rain, slowly filling the first ancient oceans. But the story of water's arrival isn't as simple as it seems. Recent research suggests that some of Earth's water may have been here from the very beginning, trapped inside minerals that formed in the solar nebula. When scientists analyze the oldest crystals on Earth, they find evidence of liquid water dating back billions of years, hinting that our planet's relationship with water is even older and more mysterious than once thought. The truth is, the origins of Earth's water remain one of science's most intriguing puzzles, with new discoveries constantly challenging old assumptions. Meanwhile, the relentless bombardment continued. Some of the impacts were so massive that they nearly destroyed the planet, melting huge portions of the crust and sending plumes of vaporized rock into space. These cataclysmic events didn't just shape the surface. They also played a crucial role in mixing and redistributing the elements that would one day make life possible. The energy from these collisions helped drive the process of differentiation, separating the planet into layers: a dense, metallic core, a thick, rocky mantle, and a cooling, solidifying crust. It's almost impossible to overstate how hostile the early Earth was. Temperatures soared, the atmosphere was thick with toxic gases, and the surface was constantly being reshaped by fire and fury. Yet, in this crucible of destruction, the foundations for everything we know were being laid. The water that would fill our oceans, the minerals that would build continents, and the elements that would one day form living cells, all of it was forged in the chaos of Earth's fiery childhood. But the most dramatic event of all was still to come. In the midst of this cosmic mayhem, a collision unlike any other would change the fate of our planet forever. The next chapter in Earth's story is one of unimaginable violence, a moment when the very existence of our world hung in the balance, and from the wreckage, something extraordinary emerged. If you look up at the night sky, the moon seems calm, almost serene, a silent companion orbiting our planet, lighting up the darkness. But the true story of how the moon came to be is anything but peaceful. In fact, it's one of the most violent and dramatic chapters in Earth's history, a tale of cosmic destruction and rebirth that forever changed the fate of our world. For centuries, the moon's origin was a mystery. Ancient cultures spun legends about gods and monsters, while early scientists debated wild theories. Some believed the moon was a wandering object, captured by Earth's gravity as it drifted too close. Others thought it formed alongside Earth, both worlds emerging together from the same swirling cloud of dust. There was even the idea that the moon was once part of Earth itself, torn away by a rapid spin or a colossal explosion. But none of these explanations quite fit the evidence. It wasn't until the late 20th century that a new, far more explosive theory took center stage: the giant impact hypothesis. According to this idea, the young Earth, still a molten, unstable world, was struck by another planet-sized body, a protoplanet scientists now called Theia. Theia was roughly the size of Mars, and when it collided with Earth, the impact was so immense that it nearly destroyed both worlds. The cores of Earth and Theia fused together, while a massive cloud of vaporized rock and metal was blasted into orbit. From this debris, the moon was born. Over time, the material circling Earth cooled and clumped together, eventually forming the familiar sphere we see today. But the evidence for this cataclysmic event isn't just theoretical. When Apollo astronauts brought back samples from the moon's surface, scientists were stunned to find that the rocks were nearly identical to those found on Earth, especially in their oxygen isotopes. This striking similarity suggested a shared origin, supporting the idea that the moon was forged from the very same material as our planet. Yet, the consequences of this ancient collision went far beyond the creation of a satellite. The impact dramatically altered Earth's tilt, giving our planet its distinctive 23.5-degree axis. Without this tilt, Earth would not experience the changing seasons that shape our climate and ecosystems. The moon's gravitational pull also became a stabilizing force, slowing Earth's rotation and creating the tides that have influenced life for billions of years. Some scientists even argue that without the moon, life as we know it might never have emerged at all. But the giant impact hypothesis is not without controversy. Some researchers point to subtle differences in the composition of Earth and moon rocks, suggesting that the story may be even more complex than we realize. There are whispers in the scientific community about alternative scenarios, multiple impacts, or even a series of smaller collisions that gradually built the moon over time. While the giant impact remains the leading explanation, the debate is far from settled, and new discoveries could rewrite this chapter at any moment. What's certain is that the moon's violent birth left a permanent mark on our planet. It's a reminder that even the most tranquil sights in the sky can have the most turbulent origins. And as Earth cooled and the moon settled into its orbit, a new era was about to begin, one where the battered molten world would slowly transform, setting the stage for the first whispers of life. But before life could take hold, Earth's interior had to undergo its own dramatic transformation. Deep beneath the surface, where secrets still wait to be uncovered, beneath the surface of our planet lies a world as mysterious and dynamic as the cosmos itself. While the early Earth's surface was battered by impacts and shaped by fire, its interior was undergoing a transformation that would define the planet's destiny. This process, known as differentiation, was nothing short of revolutionary. As the young Earth cooled, the heaviest elements, iron and nickel, began to sink toward the center, while lighter elements like silicon, oxygen, and aluminum floated upward. Over millions of years, this separation created the distinct layers we know today: the core, the mantle, and the crust. But these layers are far more than just geological trivia. The core, buried thousands of kilometers beneath our feet, is a realm of extremes. Temperatures soar to nearly 6,000 degrees Celsius, and the pressure is so intense that iron and nickel remain solid at the very center. Despite the heat, surrounding this solid inner core is a swirling sea of liquid metal, the outer core. Here, the constant churning of molten iron generates powerful electric currents, which in turn create Earth's magnetic field. This invisible shield is one of our planet's greatest defenses. protecting us from the relentless bombardment of solar wind and cosmic radiation. Without it, Earth's atmosphere would have been stripped away long ago, leaving the surface exposed and lifeless. Above the core lies the mantle, a vast layer of rock that, while solid today, was once a roiling ocean of magma. Even now, the mantle is far from static. Heat from radioactive decay elements like uranium, thorium, and potassium keeps this layer in slow, perpetual motion. These radioactive elements, inherited from the violent birth of the solar system, continue to fuel the planet's internal engine, driving the movement of tectonic plates and the eruption of volcanoes. The mantle's restless energy is a reminder that Earth is still a living, breathing world, constantly reshaping itself from within. At the surface, the crust forms a thin, fragile skin, so thin, in fact, that if Earth were an apple, the crust would be no thicker than its peel. But this delicate layer is where all the action happens. Continents drift, mountains rise, and oceans spread. The crust is divided into tectonic plates, massive slabs that float atop the softer, more ductile asthenosphere below. Where these plates meet, the planet's energy is released in spectacular fashion. Earthquakes shake the ground, volcanoes erupt, and new land is born. The boundaries between plates are zones of both creation and destruction, shaping the face of the planet over eons. Yet, the story of Earth's layers doesn't end with the familiar trio of crust, mantle, and core. Geologists have discovered even more subtle divisions, like the lithosphere, asthenosphere, and mesosphere, each with its own unique properties. High-pressure minerals, such as olivine and ring, form deep within the mantle and are sometimes brought to the surface by volcanic eruptions or meteorite impacts, offering rare glimpses into the planet's hidden depths. All of these layers work together in a delicate balance, creating the conditions necessary for life. The magnetic field shields us from deadly radiation. The mantle's heat drives the carbon cycle, and the crust provides a stable platform for oceans and continents. It's a system so complex and finely tuned that even a small change could have spelled disaster for life on Earth. But the planet's internal workings are not just a story of stability, they're also a story of constant change. As the outer core slowly cools, the solid inner core grows by about a millimeter each year, a silent reminder that Earth is still evolving. And as the planet's interior continues to shift and churn, it sets the stage for the next great transformation: the rise of oceans, the birth of an atmosphere, and the first glimmers of life. The journey from a molten, layered world to a living planet was about to begin, and the next chapter would be just as dramatic as those that came before. As Earth's interior settled into its layered structure, the surface was still a place of wild transformation. The battered crust, once a sea of molten rock, began to cool and harden, but the planet was far from calm. Volcanoes erupted with relentless fury, spewing vast clouds of gas and ash into the sky. Each eruption was a chemical experiment on a planetary scale, releasing water vapor, carbon dioxide, methane, and ammonia into the air. The early atmosphere was thick, toxic, and utterly alien, nothing like the oxygen-rich air we breathe today. In fact, for millions of years, the very idea of life on Earth would have seemed impossible. But the chaos of this era was exactly what the planet needed. As the surface cooled, water vapor from volcanic eruptions and ancient impacts began to condense, falling as rain for the first time. Imagine storms that lasted for centuries, with rain pouring down on the hot, barren ground, slowly carving out the first rivers and pooling into vast, steaming oceans. These early oceans were not just bodies of water, they were the planet's first climate regulators, absorbing heat and carbon dioxide, and setting the stage for a more stable environment. The oceans played a role that is still misunderstood by many today. While forests and plants are often celebrated as the lungs of the planet, it's actually the oceans that have always done the heavy lifting. Even now, they absorb most of the carbon dioxide released into the atmosphere, acting as a giant buffer against runaway climate change. In Earth's youth, this ability was even more crucial. Without the oceans to soak up excess heat and greenhouse gases, the planet might have become a scorched wasteland, or frozen over entirely. As the atmosphere thickened and the oceans grew, another transformation was quietly taking place. The relentless rain and flowing water began to break down rocks, releasing minerals and nutrients into the seas. These ingredients, combined with energy from lightning and volcanic heat, created a chemical soup unlike anything seen before or since. It was in this primordial ocean that the first building blocks of life began to form, molecules that would eventually give rise to the complex chemistry of living cells. But the journey from chemistry to biology was anything but straightforward. For millions of years, Earth's surface was a hostile place, battered by ultraviolet radiation from the sun and rocked by frequent impacts from space. Yet, in the sheltered depths of the ocean, life found a way. The first living organisms were likely tiny, resilient microbes, able to survive in the harshest conditions. These pioneers began the slow process of transforming the planet, releasing oxygen as a byproduct of their metabolism and gradually changing the composition of the atmosphere. This rise of oxygen was one of the most significant events in Earth's history. At first, it was a deadly poison to most existing life, but over time, it paved the way for more complex organisms to evolve. The atmosphere became less toxic, the climate stabilized, and the stage was set for the incredible diversity of life that would one day cover the planet. It's easy to overlook just how fragile this balance is. The oceans, the atmosphere, and the living world are all interconnected, each one shaping and supporting the others. Even today, the oceans remain our greatest defense against climate extremes, quietly absorbing the impacts of human activity. But their capacity is not infinite, and the lessons of Earth's early history remind us just how quickly things can change. As the first sparks of life flickered in the ancient seas, Earth was finally ready for the next chapter, a world where continents would drift, climates would shift, and life would rise to dominate every corner of the globe. But the story of how our planet became so uniquely suited for life is far from over. In fact, it's only just beginning. When you step outside and feel the warmth of the sun, breathe the air, or watch the waves roll in, it's easy to take Earth's comforts for granted. But the deeper scientists look into our planet's past, the clearer it becomes. The existence of a world like ours is anything but ordinary. In fact, some researchers argue that Earth is a cosmic lottery winner, a planet where a series of rare, almost impossible events lined up with perfect timing. This idea, known as the rare Earth hypothesis, suggests that the conditions that make our world habitable are so unique, so unlikely, that life, as we know it, might be vanishingly rare in the universe. Consider the chain of events that brought us here. Our solar system formed in a relatively calm region of the galaxy, far from the chaos of supernova and black holes. The sun itself is a stable, long-lived star, providing just the right amount of energy, not too much, not too little. Earth orbits at the perfect distance, in what scientists call the Goldilocks zone, where temperatures allow liquid water to exist. The planet's size is just right to hold onto an atmosphere, but not so massive that crushing gravity would make life impossible. But the list of lucky breaks doesn't end there. The violent collision that created the Moon also gave Earth its crucial axial tilt, stabilizing the climate and creating the seasons. The Moon's gravitational pull generates tides, which may have helped early life move from the oceans onto land. Our planet's magnetic field, powered by the churning of the liquid outer core, shields us from deadly solar radiation. Even the presence of plate tectonics, a process that recycles carbon and keeps the climate stable, appears to be a rare feature among rocky planets. Each of these factors is remarkable on its own. Together, they form a web of interlocking conditions, each one dependent on the others. Change any single variable, a slightly different orbit, a smaller moon, a weaker magnetic field, and the story of life on Earth could have ended before it began. Some scientists speculate that there may be countless planets in the universe, but only a tiny fraction will ever have the right combination of ingredients for life to take hold. Yet, the rare Earth hypothesis is not without its critics. Some argue that life is more adaptable than we think, capable of thriving in environments we once considered impossible. Others point to the sheer number of planets in the universe, trillions upon trillions, and suggest that even the rarest conditions are bound to occur somewhere. The truth is, we simply don't know how common or rare life really is. Every new discovery, from the strange chemistry of distant exoplanets to the hardy microbes living in Earth's most extreme environments, adds another piece to the puzzle. What's certain is that our planet's history is a story of narrow escapes and delicate balances. The more we learn, the more we realize just how many things had to go right for Earth to become what it is today. It's a humbling perspective, one that invites us to see our world not as an ordinary rock in space, but as a rare and precious oasis, a place where the odds were beaten and life found a way. As we look to the stars and search for other worlds like ours, the question lingers: was Earth's story a cosmic fluke? Or is life an inevitable outcome wherever the right conditions exist? The paradox remains unsolved, but one thing is clear: our planet's journey is a testament to the extraordinary, and a reminder of just how fragile and unique our home truly is. But before we close this chapter, let's reflect on the astonishing chain of events that brought us here, and what it means for our future in the universe. As we reach the end of this journey through time, it's hard not to be awestruck by the sheer improbability of it all. The story of Earth is a saga of chaos and order, destruction and creation, chance and necessity. From a silent, drifting cloud of cosmic dust to a vibrant, living world, every chapter has been marked by events so unlikely, so delicately balanced, that it almost defies belief. Each step along the way, every supernova, every collision, every drop of rain was a roll of the cosmic dice, and somehow, against all odds, the numbers kept coming up in our favor. Think about it. If that ancient star hadn't exploded nearby, our solar nebula might never have collapsed. If the sun hadn't ignited at just the right moment, the disk of dust and gas could have drifted away, lost to the void. If the early Earth hadn't endured a relentless bombardment, it might never have gathered the water and minerals needed for life. If they hadn't struck at precisely the right angle, there would be no moon to steady our planet, no tides to shape our coasts, no seasons to drive the cycles of life. Even the invisible forces deep within the Earth's churning core, the shifting plates, have played their part, creating a world that is both stable and ever-changing. That it's tempting to see all of this as a series of lucky breaks, a cosmic jackpot that paid out just once in a universe of endless possibilities. But perhaps there's something more profound at work, a reminder that even in the midst of chaos, order can emerge, and that the universe is capable of producing wonders beyond our wildest imagination. The fact that you are here, reading these words, is the final link in a chain stretching back billions of years, connecting you to the birth of stars, the forging of planets, and the first stirrings of life in a primordial sea. Yet, this story is not just about the past. It's a call to recognize the fragility and rarity of our home. The same forces that created Earth's beauty and abundance could just as easily take it away. Our atmosphere, our oceans, our magnetic shield, they are not guaranteed, and they are not eternal. The lessons of Earth's history are clear. Everything we depend on is the result of a delicate balance, one that can be tipped by forces both cosmic and human. So, what does this mean for us? It means that protecting our planet is not just a matter of survival. It's an act of gratitude for the countless chances that brought us here. It's a recognition that, in all the vastness of space, there may never be another place quite like this. The next time you look up at the moon, or feel the warmth of the sun, remember the incredible journey that made it all possible, and ask yourself, what will the next chapter of Earth's story be? Will we honor the rare gift we've been given, or will we let it slip away? The answers are still unwritten, waiting for us to decide. But one thing is certain: the story of Earth is far from over. In fact, it's only just begun. And as we continue to explore, to learn, and to wonder, we carry with us the legacy of a planet that beat the odds, a world where the impossible became reality, and where life, against all expectations, found a way. If you found this journey through Earth's origins fascinating, imagine what comes next: the evolution of life, the rise of humanity, and the mysteries that still lie hidden beneath our feet and among the stars. The universe is full of stories waiting to be told, and our own is one of the most extraordinary of all.